I'm Gilad. I'm leading the data science guild here at Wix. And in this talk, we're going to explore together the deep connection between language and intelligence in general and the artificial intelligence, AI specifically. I wanted to have this talk for a long time because I feel everyone is overwhelmed with all the advancement and the space of advancements in AI. Tools, models come every other day. I thought it would be a good time and idea to pause for a second and have some kind of a overview of this connection, which I think is the core connection that led to this revolution. Hopefully it will give you some better understanding of AI, because we will start from high level and we'll deep dive into the internals of LLMs. So let's start with this statement, or this fact, that human intelligence is most correlated with language. But the question is why? Why is it correlated with vision, for example, where 70% of our neurons, brain neurons, are assigned to vision? And the answer is very, very simple. It's because the language exists for communication. Everyone, either in nature, even if it's animals or humans, or even between computers, use language for communication. And basically, words made us, humans, the rulers of the world. It was the development of human gossip and the ability to chat about abstract concepts, not only specific ones, that made humans diverge from other species. Complex communication, like gossip, can only be achieved with a proper shared language. And the Tower of Babel here is a good example when you take away this common language from people, so they cannot communicate between each other, and there is a total mess. So basically, eventually, that's why AI moment happened only in November 22 with the appearance of ChatGPT, and not 2 years before, when OpenAI actually kicked off the Gen AI revolution with the pioneering image generation, DALL-E. So let's start and deep dive into how LLMs, how AI actually learn. Very in short, it's just like humans, okay? And we see shortly how. So first, let's decompose this term LLM, large language model, and understand what does it really mean. So we start with a model. Humans build models to represent the world, whatever domain it could be. It could be physics, biology, chemistry. You take examples from the world, from the real world. Then you build a model out of these samples to describe the world as accurate as possible, and as accurate as is, that would be better afterwards, because we are doing all of this to take actions and to predict back on the real world. Like forecasting weather or stocks market. We can model ballistics to build a system like Iron Dome, or model car traffic and build navigation applications. So if model is representing the world, a language model represents the language. Once I have a good language model, I would be able to understand and generate text automatically and reliably. And the way they do it, they're using a feature that we all know from our phones, from IDEs. It's the autocomplete, next word prediction. By within the process of scaling this next word prediction to documents and predicting the next word for billions and trillions of time, a large language model is built, and this is the LLM. The machinery behind the LLM is called neural networks. This neural network is physically stored in the computer to represent the human language. To build artificial intelligence machine, scientists thought of imitating the most intelligent machine they knew, which is the human's brain. Our brain is constructed out of 100 billion these neurons. Each neuron is doing some very, very basic operation. On the left, you can see a biological neuron. Such a structure, it gets inputs from neurons that it's connected to, sum them, aggregate them somehow, and fire an output based on some threshold. On the right, you can see the first artificial neuron invented by Rosenblatt already 70 years ago. It's called a perceptron. It does exactly the same. It aggregates these inputs, weighted sum them using the weights, and weights are the magic, or weights are the things that the LLM learn. And then some activation function. In the neurons, it's like a sign above a threshold, and then it was developed more sophisticated ones. It just output with weighted them, multiplications, addings, and fire out an output. The amazing stuff here, that this simplistic prediction machine actually stands from 70 years ago until today, the modern LLMs. I think this is amazing, and we will touch it later again. So basically, the neural network are just layers and layers of such neurons, and ChatGPT 2022 already had such a neural network, which is 175 billion neurons, nearly 2 times bigger than the human's brain. So next word prediction. This is how LLMs learn, and this trivial operation is so fundamental in LLMs. I want to review it step by step. So in the first step, we get a sequence of words. LLMs learn to predict. Then we are hiding the next word. So we have a context LLMs learn to, and we ask the LLM to predict the next word, which is predict here. The LLM predicts what it predicts. For example, it predicts generate. This is not the correct ground truth word in the red one. So we compute so-called loss out of this error. And we are back propagating this error into the network. We are fine-tuning the parameters, all the weights on the 175 billion parameters, and we iterate over and over and over again. So given just only one sentence, 9 words, we are repeating this process for 8 times, using a sliding window, going, advancing word by word, and doing this process we just saw. So now think about being able to scale this process into billions of documents, hundreds of billions of sentences, and trillions of tokens. Swallowing these tokens, you can get this damn gigantic, powerful Pac-Man machine. So this process is called self-supervised learning, and is known as the miracle of AI, because that process of scaling this trivial operation made these powerful LLMs. The amazing thing is that is basically it. That's all. Mostly that is all. So the immediate question to ask is, how come these nearly silly next word predictor machines became so powerful that they now threaten the whole humanity? So I will give 6 main reasons for that, and that will cover most of our talk. The first one, surprisingly enough, although they're doing only a single word prediction each time, but when you do it trillions of times, you get a very, very deep knowledge of language. It knows the syntax perfectly, it understands the semantics, and it has the whole knowledge of humanity, because knowledge is mostly encoded in text. Wikipedia, for example. This is the main source for this LLM to learn. So let's even dig deeper into how AI and LLMs actually see text, and how text is represented inside the LLMs. So basically, it's not words called tokens. These are the language units that AI came up with. There are efficient constructs that could be full words or subwords. Here it's demonstrated that the AI came up storing and understanding a token. Instead, you take invent, all these permutations of invent, invention, inventor, invented. It came up with that it's better and more efficient to store it as a verb, as the root invent, and all the suffixes that are used elsewhere in the language. However, since AI is a machine, it doesn't really see words and not even tokens. It sees numbers, and it presents and stores these words or tokens as array of numbers, so-called embeddings. These embeddings happen to encode the semantics of the word, of the language, based on the context they see around. Here you can see an example. Words are represented as an array of 7 numbers. So each word in the LLM, here in this demonstration, is encoded and represented as 7 numbers. These 7 numbers are called, the numbers are called dimensions, okay? The numbers here are between -1 and 1. And they actually encode the semantic aspect of the word. So here you can see an example that cat is a 0.6 living being, a 0.1 a human, and -0.7 royalty, where a queen, on the other hand, is 0.8 living being, 0.8 human, and 0.8 royalty. So basically, it encodes the semantics of the word within these dimensions. You don't really explicitly have them in an LLM with these wordings like human being and royalty and so on, but basically the dimensions are the semantics of this of the word. So this is the representation inside the LLM. Today, LLMs embedding size are not 7, but 3,000. Okay, so the bigger the size is of this embedding, the more intelligent and the expressiveness of this representation. So if the embedding size is 3,000 dimension, so you can think of it as a point in a 3,000 dimensional space. Here it's illustrated only in 3 dimensions because we humans can perceive only 3D, like we cannot perceive, the whole spectrum of vision and acoustics. We are also limited in perceiving only 3D. But AI can. AI is not limited as us, and AI can really see and understand in 3,000 dimensional space. So the representation of the language inside the LLM is very, very, very rich. And the whole language is presented in the LLM this way. So here you can see cat and dog are semantically very close to each other. So that's why you can see them here closely together inside or within this space. And cat and car only separated by 1 character, but they are very separated, not similar in this space. So this space actually demonstrates what the LLM sees or how LLM sees inside language. The second reason why these simplistic next word prediction machine became so powerful is that actually language is compressed model of the world. You remember, we want to represent the world. So language is a compressed model of the world. Language is not just a random text. Okay, it's a compilation of thoughts. It's the knowledge, literature, whatever. So training on language is effectively training on the whole humanity's cache thoughts. So by learning language so deeply as LLMs do, so you actually learn the word that generated this language. So LLMs actually encode and compress the DNA of humanity. And that's why it's so powerful and so helpful for us humans. The third reason is the LLM machine itself, which is called transformer. The transformer is a new type of a neural network that we saw that Google came up with on 2017, built semantically or schematically with only 2 modules, but with a lot of them stacked on each other, which is attention and MLP. The attention was the real breakthrough, so we'll touch it in a second, but beforehand is the MLP. And MLP is a multi-layer perceptron. Remember, this perceptron 70 years ago, this simplistic one, same thing, just in a larger scale. So that's really amazing to understand that current LLMs really use technology from 70 years ago. So AI didn't really start in 2022. This perceptron, you can see it here, okay? It's the same one, and we'll touch it again afterwards when we talk about scale. So the next is the attention. And the attention mechanism solved for the first time the inherent problem or the inherent difficulty that exist in text, and that's why text is much harder to understand than images. So if you know how to decompose language well, so you have a lot of power. Any text, and the difficulty is that any text has long context dependencies, which mean that every word in a text can influence all other words in the sentence or the paragraph, even they are very, very far away. And attention managed to do this for the first time. If you read the book, it's not hard to imagine that if you change something in the first paragraph, you can influence the whole story afterwards. So attention mechanism exists exactly for that, to understand which parts related to other parts in the sentence. For example, here in this sentence, the animal didn't cross the street because it was too tired. The word "it" refers to animal and not to street because of the tired that comes afterward and influence it. So the attention mechanism learns this interaction between words from trillions of such interactions it saw in the data. This turned to be an extremely powerful algorithm. This transfers as well neural networks here for already 9 years, which is an eternity in AI terms. And the reason, because they are very GPU friendly. LLMs basically operate these weights and the multiplications and additions for trillions of time, not much more than that. Elon Musk said that LLMs are basically 90% dot products, that's all. And that's the beauty of it. They took a simplistic or very simple thing and scaled it up in a huge scale. And if we're talking about the scale, so we call this pipeline that we saw before, the next word prediction, while trained LLMs repeat it for 30 trillion times, you can get something very powerful. Human, average or human, we see orders of magnitude, even 1 million times less words in their whole lifetime than LLMs see in their training. This difference in scale is not a detail. It's not a detail. It's a major reason why LLMs, why this simple objective next word prediction became so powerful and gave even a non-conscious machine, okay, this amazing ability and capabilities. This is also the main reason, or the main difference before the ChatGPT and after the ChatGPT, because remember, attention came 2017 with transformers, and ChatGPT was 5 years later because it was backed, the backbone, there was GPT-3 with this 175 billion parameters neurons creature. The fifth reason is emergent capabilities. These are the capabilities that were not designed upfront, and they surprise everyone. And the most notable one is reasoning. Reasoning demonstrated of thinking before answering, right? So it started from chain of thought. This and led to a better context for the LLMs to answer questions, and led to a more powerful and a complete different type of models, of reasoning models that we see today. And the last one, and I kept it for the last one, is the meeting of AI with software and the revolution, or the second big bang after the ChatGPT that we are all experiencing today, and the rest of the talks is connection between AI and software. But with the context of language and intelligence, the thing I wanted to give a note here is that LLMs are doing so well in code because computer code is actually text of instructions for machines. So it's a much easier language than human language. It's much more formal and structured one. So, are LLMs the eventual AGI machines? Everyone talks about the AGI. So, after we saw all the deep dive, all the power of LLMs, let's review a little bit about the caveats and the limits of LLMs. And the first one is reasoning, okay? Humans compile a thought and then turn it into text, okay? This is reasoning. Language is mostly a downstream of a thought. But LLMs, or AI, unlike humans, there is no separate such a prior step of having some thought and then compiling it. But for LLMs, language is the thought. So language, so people say reasoning is not, LLMs reasoning is not really real reasoning. And the second one is the irreversibility of LLMs. You can think of LLMs as trees, as a prediction trees. While they are progressing word by word, next word prediction, each time they predict the next word, they actually take a new branch and then follow it. But once you went this way, no way back. Just one-sided. That's why Andrew Yang called it LLMs behave like writing without a backspace. So the well-known hallucination phenomena that we know is just taking the wrong branch. And this taking the wrong branch, that's kind of an error. It propagates exponentially and compounded exponentially down the tree. So there are methods to mitigate it. ChatGPT already came with this second alignment step of reinforcement learning, RLHF. But you can understand the difficulty or the limit of the LLM with generating long sequences. And the third one of these limits, the third limit I want to investigate here is that real world is 3D and multidimensional. It's not only about it's not only about language. Humans don't only speak and don't communicate, they are hanging around in the physical world, which is very 3D and multimodal, okay, of geometry and physics and dynamics. And that's why currently there is a big hype of alternatives to LLM, such as world models mostly advocated by Yann LeCun. This kind of so-called physical AI models simulate how the world evolves, okay? They represent the world as states, predicting actions and what would be the state after this action. It's a totally different approach than LLMs, even multimodal, that are for reasoning or for generation of text. And really recently works said that there will be no such one model. There will be spatialized models, okay? Not the same model that fold proteins will be the one that fold our laundry, okay? So, to summarize, to AGI or not to AGI, people speculate that, number one, even Yaniv talked about it before that, and if AGI will come, then software will be coding, or a job will be the last thing that we will be thinking of. But in my opinion, this is not the right question. Because we're talking now here about capabilities, about intelligence, and not whether following humans or not following humans. You want them to achieve, you want these AI to achieve the same goals, but not necessarily do it like humans. So when humans wanted to run as fast as the cheetah, they invented wheels instead of legs. Okay, they did it differently. Or they don't do math as humans do, but they definitely do it better, right? And then all humans, and they do it faster. If you don't want them to do it, you don't want them to do it like humans, because you will go backwards. So AGI or not AGI, in some aspects, AI is already doing better than all humans. They are masters of words like no other human. They have all humanity's knowledge in their head. They're keeping up to date is already solved thing. Remember at the beginnings, a lot of hallucinations about knowledge, already solved. They are connected to other external resources and capabilities using tools, and soon they will be connected to each other. So most of the world is operated by software, and we see that AI is already taking over software. So I summarize with this post I recently saw by Yuval Noah Harari, which actually summarized the whole talk, okay? He says, human civilization is built on words. Since more words made us the rulers of the world, humans have been tempted to identify with words. However, everything made of words will be taken over by AI. Even the words spoken by their inner voices inside our heads will be shaped by AI. So humanity's quant for 2026 is, when my words don't belong to us or to me, who am I? So his suggestion is very, very surprising. To remain free, it's time for humans to identify less with words and to make a spiritual leap that we have avoided for millennia. And now is the time to find the truth that lies beyond words. Thank you.